Okay, hello everybody. So we're going to take a look at the following question. Um, we are looking at elastic collision in 1D. However, we are looking at when both objects are moving. This is from the new text, Nelson Physics new textbook, and this is on page 242. Okay. And the question is as follows. It says in a bumper car ride, a bumper car 1 has a total mass of 350 kilos. So mass 1 is 350 kilos, and is initially moving at 4 meters per second. So V1 is 4.0 meters per second going east. Okay. In a head-on completely elastic collision, bumper car 1 hits bumper car 2. The total mass of bumper car 2 is 250 kilograms, and is moving at 2.0 meters per second. However, this is going west. Complete or calculate the final velocity of each bumper car immediately after the collision. So we're looking for V1 prime and V2 prime. Okay. All right. So what we're going to do is we're going to start out with our regular way that we do all the other questions, which is P before equals to P after. M1 V1 plus M2 V2, which equals to M1 V1 prime plus M2 V2 prime. Okay. So the only thing that we need to remember in this situation is as follows. We're going to start with 350 times 4 plus. This is 250 times negative 2.0. Now the reason why it's negative is because they're moving in opposite directions. So you've got one object that is going this way and one object that is moving this way. So of course we've got to make sure that we keep or we think about that negative. Okay. And on the other side we have 350 times V1 prime plus 250 times V2 prime. Okay, so you got this one right here, 350 times 4, which is 1400. Okay, minus 250 times 2, which is 500, which equals to 350 times V1 prime plus 250 times V2 prime. 1400 minus 500 is 900, which equals to 350 times V1 prime plus 250 times V2 prime. Now we're going to solve for V1 prime just like what we did with objects that only where one object was moving. So it's going to be 900 minus 250 times V2 prime divided by 350, which equals to V1 prime. Okay, and you end up with the following. So your final equation now is V1 prime, which equals to, what's 900 divided by 350? 2.57. Okay, minus 250 divided by 350. 0.714 V2 prime. So this is our first equation. And we're going to keep it on the side. Okay. All right. So let us go back here and let's take a look at energy now. So we're going to erase all this part. Is that okay? Okay. And we will erase it. Okay. So my EK before equals to EK after, half M1 V1 prime, half M1 V1 squared plus half m2 v2 squared, which equals to half m1 v1 prime squared plus half m2 v2 prime squared. Okay, multiplied by 2, you end up with m1 v1 squared plus m2 v2 squared, which equals to m1 v1 prime squared plus m2 v2 prime squared. Now notice that in the last equation with momentum, we subtracted the two answers, but in this one, we are not subtracting the two answers. The answer is because this is energy. We don't subtract energy. Energy is not a vector, it's a scalar. It's a scalar, so even though they're moving in different directions, doesn't mean anything. They both have energies. So we are adding the two together. So make sure you keep that in mind. Yes? I know, but the square is here. Yeah, you're right. Okay, the square is there. Okay. All right, so we're going to add the numbers in. Now this becomes 350 times 4 squared plus 250 times 2 squared, which equals to 350 times v1 prime squared plus 250 times v2 prime squared. Okay, what do you get when you do this? The whole total, I think, is supposed to be 6,600. This confirm? $6,600, right? So 6,600, which equals to 350 times v1 prime squared plus 250 v2 prime squared. Okay. All right, so this becomes 600, which equals to 350. Now we're going to plug this into here. So you get 2.57 minus 0.714 v2 prime times 2.57 minus 0.714 v2 prime plus 250 v2 prime squared. Okay, now of course we are going to expand it. Okay, so this and this, this and this, this and this, this and this. Okay, so I'll let you do that, and we'll start back the video again. All right, so when we expand that, we end up with the following: 6,600, which equals to, yes, what's the first value? 2.57 times 2.57 times 350. What do you get? 0.71. Okay, minus the second one is 0.714 times 2.57 times 2 times 350. What's the second value? 84 v2 prime plus 0.49, so 0.5. Okay, and the last one is 0.714 squared times 350, which is? No, I want you to tell me that value first. 178.8, correct? Right? v2 prime squared plus 250 v2 prime squared. Okay, now we're going to bring this over to the other side, so this becomes 0 and this becomes negative, what is it? Negative 4288. So 0.3 minus 1284.5 v2 prime plus, and those two added together is 428.43, correct? v2 prime squared. Of course, put it in the ax squared plus bx plus c format and use your quadratic equations. Did you do it already? What are the values? You get v2 prime, two values. What are the two values? Yeah, 5.0 meters per second and negative 2.0 meters per second. Now, for all intents and purposes, we're going to use just the positive value right here. just use that value. Okay, don't use the negative value. And then we are going to plug into our equation that we had from the beginning. And that equation, of course, being v1 prime. So v1 prime, which equals to 2.57 minus 0.714 times 5. And what do you get for v1 prime? What is the answer now? Negative 1.0 meters per second. Which makes sense, right? So you have two objects that are hitting each other, and of course they're going to bounce off and go in the opposite direction. I want you to think about it in terms of cars. If you've ever seen cars get into a crash, they hit each other, and then they literally bounce off, go backward. Okay, it's like Newton's third law action-reaction questions. Yes? It had something to do with complex numbers and all that stuff, and we've been using positive numbers the whole time. We're just going to use a positive value. No, this is the right value.